Good afternoon, everyone. Pleasure to have you all with us. I see we still have some people joining. I appreciate Zoom had some problems today. I hope you guys are not having any issues and you can hear and see us well. I'll ask everyone to please keep your microphones muted. Maybe in the Q&A, we're going to be allowing some for some in-person questions. But until then, before we begin, we just wanted to let you know a little bit more about the Energy Institute YPN. So to those, a huge welcome to those who have attended our events in the past, and also a big welcome to all the new participants. So this is a first workshop in a series of virtual workshops which we as the Energy Institute YPN in the Middle East are planning to be holding on a bi-weekly basis. Today we're going to be talking about data science with Ali, who it's a pleasure to have him with us. So who are we? What are we as the Energy Institute? We are the professional membership body for the global energy industry, headquartered in the UK, but with branches all around the world, including one in the Middle East, covering all the countries in the Gulf. Next slide, please, Sharta. What do we do? In a nutshell, as a professional membership body, we are working to recognize people for their professional skills via chartership status. People in the UAE may be familiar with the new program recently launched by the Society of Engineers, but this is something that kind of in the UK and other countries has been there for many years now. But beyond that, we create an arena for professionals working in the energy industry, as well as those generally interested in the energy industry. So for our members, we provide knowledge services, skills development, and good practice. But for our supporters, not necessarily members, but people generally interested in our activities, we do run a lot of events, and we welcome everyone from the energy industry and beyond who are interested in learning about the energy industry and meeting the like-minded professionals. Next slide, please. In terms of our local representation in the Middle East, Trevor and Wada are the managing director and the honorary chairman. You may have heard about them, very prominent professionals working in the energy industry for many years and thought leaders. I'm not sure if they are with us on the call, but if you join our events regularly, I'm sure you get an opportunity to meet them. Next, a few words about the Young Professionals Network itself. So YPNs around the world work as sub-branches of general, we can call them adult branches, which focus on young professionals. Well, there is the official definition is under 35, but our definition is young at heart. So it's for everyone who's interested in the topics that we're presenting to you. We've been set up. We are a fairly young professional branch in a sense that we've only been set up last year, but we've already, I think, we managed to build quite a nice community of young professionals primarily in the UAE, but also across the Middle East. And we are hoping to grow as an organization through these events. In terms of the YPN representatives, which is myself, my name is Piotr Konopka, and I'm a board member of the Energy Institute YPN in the Middle East. But professionally, I work in the energy industry as a managing consultant at Guidehouse. And today I'm joined by my two colleagues. We have Shahda Altaya, also a board member of the YPN and a senior consultant with EY, and our newest addition, Andy Webster, who's a global digital business leader at KBC, and it's fantastic that he's joined us to help us create these events and continue promoting them. With that, I'll hand over to Shahda to tell you a little bit more about the YPN activities in the Middle East and introduce our speaker today.
Thanks a lot, Piotr. Let me just start by thanking everyone for joining us today. We hope that you find this session very useful for you as well. Just to share with you a bit more about the Young Professionals Network and what we really care about, and that is the development of our members. Whether that's through growing the scale and impact of the YPN network and collaborating with different key partners such as corporates and organizations from the industry, as well as universities and research institutes to really bring the best expertise. We've thought of different ways in how we can do that and kind of bring the best value to you as our members. And that's through speaker events, such as today's event, where we get speakers sharing their key insights and expertise on specific topics. We've also done in the past, and we'll see in the next slide as well, panel discussions where we get people from different walks of life to share their different perspectives on key issues that we feel are relevant for you as young professionals. Networking sessions are also things that we're really keen on as well, and that is to really allow our members to network with other young professionals as well as energy experts and leaders who are part of the wider Energy Institute branch here in the Middle East. When it comes to your professional development, we're also here to support you, whether that's through the chartered status that Piotr has already mentioned, or whether that's through the online resources and libraries that we have that can really support you with guidance documents, with a lot of leading practices that may be relevant to you in any sector, but specifically to the energy sector. Site visits are also something that we will be looking forward to in the coming months. And these will be to key sites that are relevant to the energy sector, such as solar parks, Expo 2020, perhaps a sustainable city, and key areas where young professionals can really get a chance to see how things are done on site. Mentorship, I think that's something that we've discussed in some of our previous webinars as well. And we're working with the wider Energy Institute to bring about some mentorship programs that can really cater to our young professionals here in the region. Just to give you a quick overview of some of the activities that we've done in the past since the launch in 2019. And that's basically sitting down with you to discuss how you as young professionals can really shape the energy industry in the Middle East. We've also had some workshops, and ever since everything went virtual, quite a bit of webinars on key areas and key topics such as talent development, competencies, future of engineers in sustainability and in the energy sector. And we've also collaborated with other young professional networks around the world to start the conversation on climate change in line with our Generation 2050 initiative. And we'll hear more about that initiative after the session. What we're really hoping to get you more involved on and to really kind of bring more value to you is to have these workshops done on a more regular basis. So we're going to be having them every 2 weeks, so twice a month. And they're going to be discussing key areas that can really help you develop the right skills for tomorrow. So today's session, as you know, is about data science, but the next one for you to mark your calendars would be about emotional intelligence. It'll be a crash course on emotional intelligence, what it means, and the importance of self-awareness for you as young professionals, how you can influence yourselves and your lives as well as your environment. We'll drop a link in the chat box in a few minutes, but before that, I want to start by introducing our speaker for today, Ali Tahan, who will be sharing his insights and his expertise on data science, key trends in the market, and its applications. Ali is an internal control leader for IBM's Global Business Services. He has more than 10 years of experience advising clients on complex IT transformation programs. He's very passionate about data science and data analytics, and I'm sure that you're all just as excited as I am to hear more about what he has to say. Ali, thank you for joining us and taking the time, and I'll hand over to you now.
Thank you very much, Shahda, and Puita, for your introduction and for your kind words. I'm really privileged to have the opportunity to be part of the community today and to actually start the workshops to talk about a subject that is a key passion of mine, which is data science and analytics. Let me start sharing my screen, and we'll be going over that session today, now. 1 second, please. And share the screen. There we go. And the approach that I'm going to be following is that I'm going to go over a set of slides initially talking about what is data science, and it is aimed towards professionals who are not necessarily computer science graduates or math graduates, but rather anyone who wants to understand this discipline. And then I will wrap up with a live demo of one of the, let's say, if anyone has done any programming, there's something called Hello World, which is the first programming or the first program you write in a new programming language. So there is a Hello World for data science, which is called the Titanic data set. I'm going to speak about it when I get to the demo. So just let me go on to presentation mode so that you can see. I hope that you can see my screen clearly now. And the first, I'm going to go over the agenda. So the first item on the agenda would be, what is data science? So now it's more about understanding it, what is driving it, and why is it important? Then we'll look into data science applications. Primarily, it is touching us in multiple aspects of life, and it's not just limited to computer applications or in a technical world. Data science is almost getting embedded into every aspect of our lives. So we're gonna talk about a few examples about that. Then, since I am talking to a young professionals network, I want to share some insights on how to become a data scientist, because you don't have to be a programmer or a computer science graduate to do it. I have seen some people who came from biology backgrounds, some people who have finance backgrounds, and they learned programming skills along with the required mathematics to become a great data science. So I'm gonna talk about what skills you need and what are some good resources that you can refer to in your journey to becoming a data scientist. And I will wrap up with a live demo. And as I mentioned, it is the Titanic data set, which I will explain when we get to it. So just out of curiosity, if people can answer this question with either yes or no in the chat to know how many people have some experience in programming in particular, or any computer science databases. So if you can just put quick answer yes or no, just to get a feeling, if possible. Remote. Okay. So on the chat. Okay, so it seems to be that there's a good combination of people with some experience in computer science and some without. Don't worry, nothing's going to be too technical about this. This is just introductory, and I hope that you will all be able to enjoy it. So the first topic that I'm going to have is, as I mentioned, what is data science? Now, again, I will start off with the textbook definition of data science, which, again, I mean, it has a lot of words, but does it really tell you exactly what it means? So the textbook definition is that it is an interdisciplinary field of scientific methods, processes, algorithms, and systems to extract knowledge or insights from data in various forms, either structured or unstructured. So again, I mean, it's a combination of tools, sciences, and even systems and technologies to be able to deliver a solution to a problem or to answer some questions that we did not think we were able to answer before. So it's all about getting some new insights from data that we have. And we will look in a couple of slides more how the data is growing and how it is impacting the need for data science. And then To add more to the definition is that science is implying that knowledge is gained through systematic study, and data being as the information set of qualitative and quantitative variables. So it is a science, a new science, and it relies on other sciences in the way it works. And we will explain that later. Now, one other synonymous expression is machine learning. So a lot of people interchange the two expressions, machine learning, data science, and even there's more deep learning. So machine learning in reality is a subset of data science, and it focuses on the study on how to create intelligent agents, and which is basically driven by the ability to learn new knowledge from experiences, okay? And the focus is primarily on algorithms and programming. So this is how we are modeling or creating algorithms to help us to predict. So it's just a subset within data science. We can look more into visualization, insights, data exploration, all these kind of aspects that don't really fall within machine learning. Machine learning only covers the algorithms part, which is how do we predict the data that I have, or predict the outcome for the data that I have. And again, machine learning is all looking about patterns in data. So in every scientific field, we are always looking at data and we're trying to find patterns, and we use it to answer questions, whether it is in scientific research, whether it is in many disciplines, in engineering and even in socioeconomics and healthcare. We're looking at data and trying to understand it. Machine learning help us in achieving that knowledge or finding the insights much quickly through really powerful algorithms. And I'm gonna talk about the different algorithms or the different problems that machine learning is able to solve in particular. So one thing that is quite interesting is that people are calling data as the new oil. And you know, one of the senior vice president at Gartner Research, he mentioned that information is the oil of the 21st century, and analytics is the combustion engine. And I think it's a brilliant statement, because if we look at, you know, 100 years ago or even 50 years ago, when we look at the top companies that we have, we'd see a lot of heavy industrial organizations like oil and gas, and we see more about heavy manufacturing like steel, et cetera, et cetera. But we do have a different picture today. And we can look right now, for instance, some articles that I shared showing how people are actually considering data as the new oil. It's a general consensus, and we can look at that in the following slide, which includes the list of the top companies or the companies with the highest market capitalization globally, right? So if we look at it, these are top 10 companies, but how many of them are technology related, where they are applying applications of data science into either as an offering to other customers, or whether for their internal business operations. And here, so 7 out of the 10 companies are actually technology companies. 7 out of the 10 top capitalization companies are technology companies, where they are using and relying on data science in their operations, and also in offering it as a service to their customers. So you may not, Okay, so there's a very good question actually. How is data science different from statistical analysis? That has been used for a long time. So statistical analysis focuses on the mathematics, and this is the oldest science that exists. Then things had progressed into data mining, which started looking into the math and the algorithms. Now, in the last few years, there is a new focus with data science, which now what it's looking at, machine learning, which is looking at the algorithms and the programming. You need to have some mathematical understanding, but it is not the key requirement to utilize it. You need to understand the technology, the math, and then to apply it. increase the volume. Okay. Let me see if I can. Okay, so I will try and increase the volume here. I hope you can hear me better now. Okay, so that is why we have a lot of companies that are really valued, which is showcased by their market capitalization, and are being driven by their by the abundance of the data that they have and how they are using and utilizing it. So moving on to the next slide. So what is driving the need for data science, right? First, we look at the technological advances that are happening and the amount of the data that we are getting. Researchers have noticed and have estimated that the data is expected to be doubled every 2 years for the next decade. So if we look at the trend of what is happening, the data is growing at a really high rate, and it's unprecedented. And this is mainly driven by, the availability of the internet, social media that is generating more data. And when I say data, it is not limited to databases or to structured data. It could be a video, it could be a photo, it could be a tweet. All that is classified as a data, which now people are harnessing knowledge from it or harnessing insights by applying the data science. And as the data volume increases, it becomes more difficult to understand the data, because now if you have millions of people sharing information, it is not easy to get insights from it. And also even within an organizational space, and I'll take as the energy sector, now we have smart meters everywhere, which is collecting a lot of data. Our production units, they have a lot of sensors and a lot of systems that are collecting data. The question is that, are we actually using this data to the max? And are we getting the full benefit of them, right? And then this is a chart that shows us the growth trend in terms of the generated data. And if we look at the growth between 2014, which was about 3 exabyte, and exabyte is, this is the growth. We're often with the kilobyte, megabyte, then gigabyte, terabyte, petabyte, and exabyte. So in 2014, we had about 3 exabytes, which doubled to 6 in 2016, doubled to 12 in 2018. And this trend is expected to continue in that manner. And with that data availability, businesses want to seek insights out of it to make either better decisions or to try and solve problems. And the problems could vary, or the domain and the depth and breadth of the problems that are being handled is varying quite a lot, and is impacting many industries. Now, here are some interesting numbers, and I guess all of us would be familiar with them. We all use, well, a lot of people use Instagram, and every minute, people are posting almost 47,000 photos. Now, when we look at Twitter, almost 450,000 tweets are sent every minute. And when we look at Snapchat, users are sharing about 500,000 photos every minute. And to look at YouTube, there are about 4 million videos that are being watched. So you can look at the numbers. They are growing. They are quite significant. And, with this information that is coming, there's a lot of insight that can be harnessed. And I will be explaining some of the use cases and how that data is being used and applied. So we now talked about how the data, is growing, but what is generating that data, right? There are four key areas that are generating that data. First are the people. our daily transactions, transportation trends, online behavior, because it's all being somehow monitored. Everyone now uses a smartphone, so whatever you do, it is being tracked by either an organization or by a company. And this would open up the topic of ethics and data security and privacy, which is, again, a really big topic to be discussed, which I'm not going to be talking a lot about it. But again, I mean, the availability of the information and the ease of collecting it is now is a key driver in generating data, right? Then the next part would be the sensors. As I have mentioned, we have smart meters, smart watches, traffic sensors, weather sensors, whatever, you name it. All these sensors are collecting data, and it is being stored in a database or in a data warehouse. Some of them are, some of that data is used in real time to monitor and track things, but many organizations are not realizing the benefit of that data to be able to predict events. And then we look at the user-generated content. So this goes back to tweets, photos, videos, blogs. Now almost everyone can become an author and start writing blogs, right? Sharing the photos. So all this had increased the availability of the data. And generating it. And then the last aspect is open data. And these are government data that should be available to anyone with the possibility of distribution in any form without any copyright restrictions. So then again, people are demanding more from their government and more transparency. So again, this is adding more data. And I always like this definition. So data scientists draw digital information, the digital information they are studying from a growing list of channels and sources, including the smartphones, which I mentioned earlier, internet of things, devices, social media, surveys, purchases, internet searches, behavior. What you can think of anything, and it's probably being collected to either benefit that business or to make better decisions. So yeah, a lot of data is being generated. So now, just to wrap up the introduction of the data science, why is it important? We are looking at data that we have collected, and we use it to build models to help us predict future events or to solve problems that might have happened in the past. And thus, basically, we are looking into an insight into future patterns from past and current data. So we are actually maximizing the benefit from that data. And then we are looking at as the data is growing, we can see that it is interconnected, and we can definitely use it to derive new knowledge, make predictions, and also in the decision making. So that is why data science is important, and every company you see is talking about either artificial intelligence, robotic process automation, data science, machine learning. So all these things, the companies, they realize that they are sitting on a wealth of information that they can use to either expand their business, make better decisions, reduce costs, many use cases. And they're applying data science to do that. So since we are talking about data science, we definitely need to look at the applications and how is it being used today. And I'll talk about scenarios where, it is touching us actually on our daily lives. So we start off by looking at the problems that data science can help us. So there is classification, and this is a classic case where you want to predict something, to classify something as an outcome out of a few possible values. So for instance, you can look at the patient and you can predict whether the patient is sick or not. So this would be a classification problem. Then we have clustering, which is the idea of grouping similar objects together in a large set of objects. So as an example, this is used in customer segmentation. How do I group my customers into groups that I can provide different services, or I can do different marketing strategies? So this is what clustering is. Regression, I think a lot of people would be familiar with it, which is the act of predicting a continuous numerical variable. So demand, supply, etc. We look at anomaly detection. So now when we have a lot of data, we need to see the anomalies that exist within it and how can we do it. And then there's the natural language processing, where now we are seeing more and more computers are understanding the language. So how is that happening? And then there's the image and audio recognition, where we can see, as an example, Facebook automatically tagging people, or Google doing that. So how did it learn who that individual is, and how is it tagging that photo, right? So all these aspects are applications of data science. Now I'm gonna talk a little bit more about each one of them. So the first one, as I mentioned, is the classification, and this is the classic example. Let's say I have a set of apples and a set of cupcakes. I convert that into numerical information. So what is the weight of the item? What is the height? What is the width? What is the color, right? And I will say whether it's an apple or not. So now I am collecting the data about my apples and I'm creating records. I'll do the same thing about my cupcakes. I am collecting that data. Then what I'm gonna do, based on, let's say, if I had 100 apples and 100 cupcakes, I'm gonna use them and to train a model, okay? So I have data for 100 apples, data for 100 cupcakes, then I'm gonna be building a model that would take in the information of a new apple that I haven't measured, and I feed it into my model, and it's going to classify it as either a cupcake or an apple. So this is classification, or the simplest explanation of classification. And this a classical example that is used in many disciplines, including, for instance, in energy. It would be to identify failure of a system, or it looks into predictive maintenance with a combination of other machine learning problem-solving areas that would help us in doing that. The next area that we have in machine learning, as I mentioned earlier, is clustering. So we can see that we have a lot of objects, or a lot of records within our data. What we need to do is that, how do we mathematically group the similar records together and segregate them or segment them so that I can better handle each group separately. This is different from the classification. Classification is that I need to know whether this object is an apple or a cupcake. While in clustering, I need to know that I have a group of pyramids, but I didn't know what they were. So in this case, I didn't know that a pyramid is a pyramid. But it grouped all the similar objects together so that now I have a pyramid group, I have a box group, and I have a circle group. And that's, again, the most classical example is customer segmentation that we have. Then we look at regression, which is finding the or predicting a variable based on the input and having a mathematical model to do it. And that's used in demand and forecast predictions, weather predictions to some extent, stock markets with, it looks at more into time series and with some more advanced regression techniques to do the prediction. But then again, we are trying to predict a numerical value. Then within the anomaly detection, we have a lot of data. Let's say this is time. It could be over the span of 10 years. I have plotted it, but I've seen some unusual behavior. Like we can see that, the height is always here okay, but here it just spiked here. So this would help us to look more into that data set, understand what has happened, and connecting all the available information to understand that anomaly and how to either benefit from it when it happens or how to prevent it. So that's the key thing that is focusing on anomaly detection. And when we look at the natural language processing, so then again, a computer is a machine that only knows zeros and ones, okay? Your phone at the back end, your computer is all running on zeros and ones. So when you are actually talking to Siri, it is not really speaking or working at the same wavelength as the human being. So what is happening is that it is taking that word, converting it into a mathematical entity that is then used for modeling to actually to understand. So like for instance, looking at the male, female, man, woman, king, queen. So it draws this associations and it would help us in either building chatbots, or it would help us in having, you know, text-to-speech converters, a lot of applications of natural language processing. And, you know, mapping the countries to the cities. And again, there's a lot of math behind it on how it is happening. And then last but not least, we have the the title, I have not updated it. This is supposed to be image recognition. Anyway, I should have updated that version, but what is image recognition? So if we can see what is happening right now, you see a lot of applications where you can upload a photo and it will detect what is in a photo. Is it a bus? Is it a building? Is it a person? Is it a face? And it's even going to levels to look at how is that person behaving? Is the person smiling? Is the person sad? And you have some applications out there that are actually accurate, and even they are used for age prediction and all that. But this is, again, one of these controversial topics where a lot of the companies saying that this should not be used for it needs to be controlled in terms of the security tracking and all the applications that are out there. And some organizations are not working on using that in terms of police agencies or that. But again, I mean, the technology is out there. Things could be changing if there are proper regulations in place for it and on how to use such facial recognition techniques. So moving on to some applications, I'm going to look at a particular solution, and then I'm going to look at an industry and what is happening with it. So first, we look at a recommender system. I think a lot of us are using Spotify, YouTube, Netflix, Amazon, and if you have noticed, it's always recommending, whether it is music or recommending videos or movies. It is learning from your behavior and the behavior of customers, of other customers that have similar behavior as you do. And they try and recommend whatever service or product that they are offering to you. And most of the time you end up either watching the Netflix movie or buying the Amazon or the item that Amazon is predicting. And again, this is all based on past knowledge that is collected from the behavior, your behavior and the behavior of other customers to recommend things to you. So now it's more customizable. It's more customized and you would find more value in it. Then there is the chatbot. And again, there are quite a few ones. I picked Rashid, which is a very interesting application used by the government of Abu Dhabi. And what it does is that it's a chatbot. You can go to it and ask it questions about government-related services. So you can go to the chatbot and say, how do I renew my driving license? It'll answer your questions. It'll provide you with the information that you need. It can ask you follow-up questions. Was that helpful? Are you interested in finding out more about how to register a vehicle? So again, this is where they're applying natural language processing to build a chatbot to answer your questions. And when we look at image and text recognition, I guess we all have some experience whether using Siri, Google Assistant, Shazam. all these aspects that are happening is that, you know, we are detecting things. Shazam is converting your song into, or is listening to your song, and it's telling you what that name is. So again, this is where natural language processing comes into play. If you have seen some of the interesting applications, is Google reverse image search. So you can upload an image to Google and it will search for that image for you. So again, this is where some of that image recognition, speech recognition coming into place to apply these applications. So now the first three were more focused on a type of application. The last two, I'm looking at an industry. So when I look at the financial sector, there is a lot of work happening in terms of fraud and risk detection. Companies are trying to predict fraud and risk detection, credit score prediction, customer segmentation. And they are all very important aspects to any financial institution to reduce the fraud and risk and make sure that the credit score of the people are predicted correctly so that they wouldn't have any losses, and obviously customer segmentation to increase the customer value. And in the other industry, in healthcare, there's medical imaging where there's a lot of research in using data science to look at x-rays and MRIs to diagnose patients. There's also predictive analytics in healthcare. So based on a patient record, what is the probability that they would develop certain disease or certain condition? And then there's tracking and preventing diseases. And actually right now, a lot of data scientists, they're either volunteering or working with institutions to track COVID, trying to understand how it is being spread, things like that. So it is going, or is getting involved in almost every aspect of our life. That's the beauty of data science. Now, since we're talking to an audience of, or I'm talking to an audience of energy and power, I put a few examples that are more common and in the energy sector. The first one is looking into the failure probability modeling. So, you know, you have your generation or your power stations. How can you detect the failure and when would it happen? So we learned from our previous collected data to be able to predict future failures. And in this case, you can actually do predictive maintenance to fix the issue before it actually becomes into an outage, right? Then again, the next use case is outage detection and prediction. We're looking at how's the weather impacting the power grid? What are some of the events that are happening in smart meters that are resulting in an outage? Real-time filtering of the output of, real-time filtering of outage inputs and recognition of the outage type. So all these things we are using to help us in detecting outages and predicting when they would happen so that we can take necessary measures to prevent it. Dynamic energy management, how do you manage the demand and supply, and how do we balance the production that comes with it? And then last but not least, improving operational efficiency. So again, from a lot of the data that we have, there's work or there's a possibility to use real-time monitoring to improve the operations. So that would conclude the applications section. Now we are moving on to how to become a data scientist. As I mentioned, a lot of people are not necessarily coming from software engineering, but are becoming data scientists. However, you are still required to have some understanding of computer science to be a successful data scientist. And also you need math and statistics. So looking at the first column in terms of computer science, a data scientist should have good understanding of programming principles, algorithms, data structures, databases, big data, cloud. Also in terms of languages and tools, they're recommended that the most common ones are Python, R, Julia, SQL, SPSS modeler, and MATLAB. So these are the tools that are being used to solve the problems. But I have some good news. which will come later when I do my demo. Math and statistics. You need to have good understanding of probability theory, some statistics, linear algebra, and calculus. But the question is that, why do I need it, right? Because we are dealing with mathematical models, having good mathematical understanding will help us to determine which model am I going to use to solve my problem, and or which algorithm am I going to use, and how can I assess the performance of the model. And as a first step, actually, for working or building the models, that we need to look at the actual data and understand the mean, the average, the distribution of the data, which would help us in making the decisions on which algorithm to use. And last but not least, there's domain and business knowledge. A person has to have good understanding and sufficient breadth and depth of knowledge in the discipline that they are servicing. So usually, to be a successful data scientist, you shouldn't just focus on the math and computer. You need to understand the business that you are working with. And that is why, as I have mentioned, you are seeing people who are coming from other disciplines and becoming data scientists. In terms of other softer skills, I would say that the data scientist would need is storytelling, because you could be the greatest data scientist, you solve the problem, but if you cannot communicate it either visually or through an executive summary that to the executives, then your solution might not be heard, or the answer that you have found might not be heard. So it is very important to be a great storyteller so that you would get your message across. And then a business analyst, you need to ask the right questions and find the right answers. And this is what business analysts primarily do. They're helping the business by asking the questions and finding the answers. And last but not least, data engineer. We look at the data with a mathematical mindset. We learn we do things like data extraction, exploration, hypothesis testing. So they are very critical when we look at that data. So we shouldn't just take the data for granted. We need to understand it. And here are a few great resources to start. Kaggle is a great data science community that offers data sets, code, articles to get started. Udemy is offering a great course, Introductory to Data Science. Coursera has a different course, so there are some of the top courses that are out there. In terms of professional certification, IBM is offering the IBM Data Science Professional Certificate, which comes with courses and a capstone project to apply the knowledge. And then Towards Data Science is an excellent data science blog. You find a lot of articles, a lot of code, and you can learn a lot from those resources. Now we will be starting the live demo. And as I mentioned, what I would be doing was working with something called the Titanic dataset. And to start off, the Titanic dataset is available on Kaggle, which I have just mentioned. And it is a very simple problem to solve. We have the data of the passengers of the Titanic, and I know whether they have survived or not. So the question at hand right now is, are we able to build a model to predict whether a passenger would survive or not? Okay, so now when we look at the data, the file provides some explanation. So we have the survival, they survived, yes or no. What was the class of the ticket? What was the sex of the patient? Not the patient, the passenger. What is the age? Do they have any siblings or spouses? Do they have any parents or children on the ship? What was the ticket number, the passenger fare, cabin number, and embark? So we see some information there. Now, how can we use it? And when I say use it, I only will look potentially at these columns that I have highlighted to predict the last column, okay? So this is the first question. Now we start making hypotheses. What are the key features or key columns, let's call in our data, that would help us determine and predict? So we can make a hypothesis that the sex and the class have good indication or actually correlated to predicting whether the person is going to survive or not. Okay, so this is the data set. Now, as I mentioned earlier, I have some good news for you. And the good news is that now you have so many tools that you can actually feed the data to it, and it will build the models for you, train them, assess them, and tell you what is the best model. One of these tools is IBM Watson Studio, which is quite simple to use. And then I'm just starting a new project to test it out, and I'm going to call my project Titanic. I have my storage. So now I just created my project. So this is the first step. Now, once the project is created, it's going to show me the available assets that I have. So right now, I don't have any assets. My assets, it could include the data. So in this case, I need to upload the data to the tool. So I'm going to take it from here. Okay, here. So I'm just going to add the data, personal documents. So my data is stored here. I had already downloaded it from Kaggle to save some time, and I'm going to upload it here. So this is my train data. So now I put my data there, and it is loaded. Once I do that, I need to create what is called an auto AI experiment. And this is the tool that would actually run the predictive models for me and will give me an outcome. So I'm going to call it also Titanic. And I will set it up. So now I have created the tool, and now I'm going to create my auto AI experiment. So I need to select the data that I want to train. It already looks at whatever I have uploaded, and that would be the train data. I'm going to select it. So now, this is the beauty. It is telling you, what do you want to predict? So now I have the list of the columns that we looked at earlier on the Kaggle web page, and I could select the column that I want to predict. So I want to predict survived. Then I can go and configure the experiment that I want to do. So usually in data science, it is extremely important to perform what is known as train test split. So when you have a certain data set, you use about 80 to 85% of that data to train and build your model, and you keep the remaining 20, 15% of data to validate the model that you have built. Because again, in our case, all our data includes the value, whether they have survived or not. So I'm going to train it with 85% of the records, and the remaining 15%, I'm going to calculate it or predict it using the model, then compare it against the actual value that I had. And this is how we measure the accuracy of the file. Then I need to select the columns that I want to use in the prediction. I would leave the passenger ID, I would leave the name out, and I would leave the, what are the other ones? Sex, age, arch, the ticket. Okay, so these columns I will not include it because now they are unique to a passenger. And when you use such unique information, you are overfitting your model, and it will only be usable for the data that you have. But if you use it to predict something that it hasn't seen before, it's going to give you really bad results. So you need to always consider the data that is not unique to a record. You're not identifying someone by their ID or by their name, but age, height, length, these are things that we use in the prediction. Okay, so now I'm going to save my setting, and I'm going to run my experiment. So what the Auto AI is doing at the moment is that it took the data that I have provided with, and whatever I ask it to predict, which is the survive column, and it is using the columns that I have selected to build that model. Now, this should take about 10 minutes to load. So what I'm gonna do, in the interest of time, I am going to look at a test that I did earlier, or I did yesterday, which is giving me the outcome. And this is the test. Okay. So the new one is still running. The old one, I have run it before. So what did the tool do for me? It used different algorithms. If you can see, we have random forest classifier and XGB classifier. And they are typically some of the best algorithms that are used predominantly today to solve a classification problem similar to what we have, right? So it ran the algorithm. Then it applied more aspects, which is, I'm getting some questions. Yes, I'm aware. So I'm just gonna wrap up the demo. So it ran multiple algorithms and it applied different things to optimize the outcome. There's something called hyperparameter optimization. Each algorithm has some parameters that you can tune to increase the accuracy. It is doing some feature engineering and it is looking at optimizing another one. So it kept trying different algorithms, applying different techniques until it found the algorithm with the highest accuracy. So in this case, this model had the highest accuracy of 83%, meaning that when I give it a value, or when I give a passenger record to the algorithm to predict, I would have, I'm 83% sure that I'm gonna get the right outcome, whether they have survived or not, which is a very good prediction value. And you know, you can look at the model, the outcome of it, confusion matrix, it is used in the classification. And then I'm gonna go back to the hypothesis point. What are the important features? So we have the sex and the class. So this is meaning that sex is very important in determining whether a person has survived or not, which logically speaking makes sense because we tend to let, or even in Titanic, the females would have high priority into boarding the lifeboats. And we can look at the age also. Children would have better preferences. And then the class, because people who have first class would actually have a better chance than someone who is from coach or economy, right? So this kind of reiterated our hypothesis, and you know, we could only do it in a matter of 10 minutes. This is a very simple problem, but in reality, there are many more complicated, which takes a lot of work to prepare the data, understand it, and to come up with the right hypotheses and to build the predictive models. But I just wanted to start with something simple to give a flavor to everyone, which I hope that you have all found it useful. And you know, just going back here, it is running the algorithm and it's showing me the output every time. So this is the end of the demo. I think if anyone has any questions, I'll be more than glad to answer them.
Thank you, Ali. It was a fantastic presentation. And I'm aware we're running out of time slowly, but I think we still do have a few minutes if you have any questions. So please do feel free to ask them in the Zoom group chat.
Okay. Rohan, thanks for your question. So overfitting is very important to watch out for when working with in any data science projects. What you want to achieve is to have a model that can deal with the unknown. So if you create a model that would work only on the data that you trained it with, and you give a new set of information to use it to predict, or to use it to get a prediction, and it is incorrect, then you have overfitted your model. And in this case, what needs to happen in terms of ensuring that the data is not overfitted, we use something called train test split, which I had mentioned. So we can measure the accuracy, and that is not depending on what I have trained my data with. There's something called cross-validation of the data. And this is a bit more complicated situation, but what I do, my train split, I'm gonna run it multiple times, leaving one aspect out, or one subset of the data out. So I train it with, you know, like, actually, let me show you an example for it. I have a diagram. Okay. I should have included that. But what it is, cross-validation is a technique that is used to ensure that the data is not as overfitted. And here, so what it does, you run multiple iterations of the same data, leaving one part out. So first, I'm going to train my data with the gray data, and then test it on the blue. Then I'm going to do it again by moving to another block. And this way, I'm trying to eliminate the overfitting. I hope that answered that question. Now, let me look at here. Do you have any suggestions for energy, electricity related projects? There are a few that are available on Kaggle. I'm gonna look for a few, and I could share it with Shada and Poiter, and perhaps you can get that link from there. Can you please elaborate on how to carry out the next steps? I mean, if we have the other variables, how can we predict the survival? So this is where the algorithm is using the input that we are providing to predict the outcome. So in this case, I am giving it the age, I'm giving it the sex, the class, which are the three key important features. And the model was trained using the algorithm, which is known as random forestry, to predict the outcome. So it all goes back, learning from your past experience. You always need to have some historical data to build a model. Once you build that model, you tune it and you try to maintain it, and then you pass on new observations or new data to use it to predict. So again, always you're learning from what you had before. And you know, similar to regression, right? Regression looks at your data points that you have, and then it would find the best fit line for the data, which now you can use it to predict unknown X. So you can predict the Y for X values that you have not observed before. So I hope that answered that question.
I think we have a couple more questions, but perhaps we can take them offline and get back to everyone, if that's okay. Yeah. Just to make sure that everyone can kind of meet their other engagements. But thank you, everyone. I'll just quickly share one final slide to tell you a bit more about our EI Generation 2050 initiative. And if that's okay with you, Adi, I'll just start sharing the screen.
Okay. Yeah, sure. I'm going to stop sharing there.
All right. So just to tell everyone a bit more about this initiative and how your voice kind of matters to us in getting the feedback and learning a bit more about what is your priority when it comes to climate change, when it comes to access to energy and energy security. And that's kind of the main heart of behind this initiative, pushing the agenda, getting young professionals engaged and speaking about these topics and making sure that their voices are heard. So please go ahead to our survey and answer it, and feel free to share your views, which we will take into consideration and share with you the report towards the end of the year. And we'll also drop in the chat box the link to our next event, which will be about emotional intelligence, as we mentioned earlier. And we hope to see you there as well. Thank you, everyone. And if you want to get in touch with us, you can just get in touch on those details here. And I'll be dropping the link on the chat box right now. And with that, I think we can close. Thank you, everyone. Thank you, Ali. If you have any closing remarks.
Thank you very much for giving me this opportunity again, and I really enjoyed talking a little bit about data science. If you have any questions, please just add me on LinkedIn. You can ask me about it, and I'll be more than happy to help you out if you're interested to either get started on this in this discipline, or get some ideas on where you can apply it.
Fantastic. Thank you very much, Ali. Thank you very much, everybody, for joining. And yeah, we're looking forward to seeing you all at our future events. Have a great day, everyone.